The Rock Whisperer. Do you hear the earth talking to you?
So, how are stars formed? Well, let's find out. Stars are formed when clouds of gas, usually hydrogen, condense because of the gravity that's pulling them together. Like I said, it was hydrogen and helium, usually left over from the formation of the universe, and also debris from the explosions of other stars that existed thousands of years ago. This process takes a long time, about 50 million years or so.
Heat comes from the collapse of matter and from friction. This continues until the temperature is about 1.5 times 10 to the 7th degrees Kelvin for nuclear fusion to occur. So take your hands, press them together really hard, rub them as fast as you can. You're producing heat, and just picture that in space. All this matter is condensing into a very dense ball, and the particles are rubbing together really, really fast, creating a lot of heat, and then nuclear fusion occurs because of that immense heat.
Right, so nuclear fusion is when lighter elements join to form heavier elements. This happens in stars all the time. It's usually done with helium forming hydrogen. You need 4 helium atoms to form you need 4 hydrogen atoms to form 1 helium atom, just like in the picture there. And again, it requires extreme heat and extreme pressure.
Life cycle of an average star after birth. The same heat and pressure that form the star also slowly shrink it down. So what's making the star a star is also making it smaller. After 10 billion years, the star is low on hydrogen, fusion slows down, and the helium core collapses. The outer part of the star expands quickly and becomes a red giant.
The gas is cool, and all that is left over is a very hot, dense core. That's what that picture is of there. That's called a white dwarf star. This only happens for relatively small stars. Larger stars, they have to be at least 10 times larger than our sun is. Something else is going to happen.
Heavier elements are created before the collapse. These stars die in what is called a supernova, as in that picture. One of the most beautiful things you could see in space. Massive amounts of energy are briefly created, then most of the mass is blown into space. Even larger stars may form a neutron star or a black hole, depending how large they are.
Right, so black holes. Black holes are very dense, and they have such a large gravitational pull that not even light can escape from them. You often probably think the black hole just sits there sucking stuff in. That's incorrect. It's kind of like a star, except it's got a wider gravitational field, and it's more powerful, again, so powerful that not even light can escape. They do not radiate energy, and they can only be detected because of energy of the matter that falls into them, or we can observe their gravitational pull on other objects, and that's how we know there's a black hole there.